So next, we will want to focus on the negative exponent. So for this example, we have a raised to negative n is actually equals to 1 over a to the n. So a to the n is in the denominator. So what is the proof of this one? So I will show you the proof. So for example, if we have 4, or if we have a raised to the 4 minus 6. So what do we got? So we know that a raised to the 4 minus 6 is equals to a raised to the 4 divided by a raised to the 6, right? So this one is what you learn in law number 2. So a to the 4, I have a times a times a times a 4 times. And a to the 6, we have a times a times a times a times a times a. So we have 6a here. So I need to cross out, right? I need to cross out the a with this a. Okay, I want to cross out this a with this a with this one with this one, maybe, and also this one with this one. So how many a do we left in the numerator? So no. So if I know a, I just wrote it 1, right? So how many a in the denominator? So we have 2a in the denominator. So this is a to the 2. So what about this one? This one I know that is a raised to the negative 2. So that's the reason why, right? A raised to negative 2, 4 minus 6 is negative 2. Is actually equals to 1 over a to the 2, right? So let me write it properly. So we have a raised to the negative 2 is actually equals to 1 over a to the 2. So if I want to get rid of this negative, I need to put the a to the negative 2 to the denominator. So this one, the negative disappear because I put it in the denominator. So if the negative appear in the numerator, when I put it in the denominator, I need to cancel out the negative, right? If I have an a to the minus n in the numerator, if I want to get rid of this negative right here, I need to put it in the denominator. So this is the rule. Okay, so for law number 6, we know a divided by b raised to the negative n is equals to b divided by a raised to n. So if I want to get rid of this negative, I need to flip the fraction, right? So why is that? So let's prove it. So if I have maybe 3 divided by 2, maybe I need to raise to negative 2, for example. So what I got here is 3 raised to the negative 2 divided by 2 raised to the negative 2. So remember, if I have a negative in the numerator, I can turn 3 negative 2 to the denominator, right? So remember, so that's why I can rewrite this as 3 to the 2 in the denominator. So also, you see the negative 2 exponent in the denominator. I can turn this into numerator by saying 2 to the 2, right? And it's actually equals to 2 over 3 raised to the 2 power. So you see that, right? The fraction flips in this case. And the exponent become positive for this one. So this one is really complicated concepts, but you need to know this one for sure. So number 7 is the same thing, right? If I have a raised to the negative n divided by b raised to negative m. So if I want to get rid of this negative, because this negative bothers me, right? I can turn this one into the numerator by dropping the negative, right? So you see that if it turns the denominator, the exponent becomes positive. So if I have b to the minus m, for example, so if I want to turn this the exponent to positive, I need to raise it, put it in the numerator by saying b to the m. So that's why we have b to the m divided by a to the n. So the last one is the a to the 0. So a to the 0 always equals to 1. So y is equals to 1 because we know that a to the 0, so just make it up, equals to a to the 4 minus 4. Because it's a exponent subtraction, I turn this to the fraction a to the 4 divided by a to the 4. So this is a law number 2. So this one and this one cancel out. So that's why I got equals to 1. So a to the 0 always equals to 1. So this is what you learned in previous math classes. So hopefully this helps you.